It was called a soda bottle, and people chuckled at its sluggishness. But this fighter became the last line of defense between Japanese attacks and American aircraft carriers. The machine, which was born in a rush and lost the first competitions, unexpectedly found itself at the center of the fiercest battles of World War II. It was credited with the heroic defense of islands, desperate dives where a pilot's fate was decided in a fraction of a second, and catastrophes when its weak landing gear broke the plane right on the deck. This fighter saved lives, but also took them, offered hope, and turned combat into a game of survival. Why did the Wildcat become a legend, despite the mockery and defeats? This story has everything, from scandalous failures to incredible victories, and the most unexpected secrets await you at the end. In the mid-30s of the last century, the American fleet was at a turning point. The world of aviation was rapidly transitioning from biplanes to monoplanes, and every company involved in military aviation understood. Only the one who could offer something truly new would survive. The Grumman Company, whose aircraft had previously served reliably on aircraft carriers, decided to prove it could step into the future. Their first prototype, designated the XF4F1, was in many ways an heir to old traditions. It was a sturdy metal biplane with an enclosed cockpit and retractable landing gear, which looked progressive for its time. But against the backdrop of rapid changes, it seemed more like a cautious step forward than a real breakthrough. While Grumman was preparing this machine, a new rival, the Brewster Company, entered the scene. It was they who offered the fleet a fundamentally different approach, the XF-2A monoplane, which would soon be known as the Buffalo. In the eyes of the military, this looked far more modern, and unexpectedly for everyone, Grumman lost its leadership. In July 1936, a new contract was signed, and now the terms were tougher. The XF4F2 prototype was obligated to be a monoplane. The designers went to work in a rush, and a year later, on September 2nd, the new aircraft took to the air. In tests, it showed respectable results. The speed exceeded the competitors, but the reliability let it down. As a result, Brewster's XF-2A was declared the winner, and it was the one that went into production. For Grumman, this decision was a painful blow. The company, which was considered the main supplier to the fleet only yesterday, found itself in the shadows. But the Wildcat's character was already evident here, in its refusal to give up. Instead of closing the project and admitting defeat, the engineers decided to bring their brainchild to perfection. They understood that the XF4F had hidden potential and were ready to rework the design to regain their position. Thus began a history of perseverance and a fight for the right to exist. And although few could believe then that this machine would become a symbol of the first years of the war in the Pacific, Grumman was preparing for a comeback step by step, and with it, the birth of the fighter that would be named the Wildcat. Grumman's chief designer, William Schwendler, found himself in a situation where time was running out. The fleet demanded quick and tangible results from the company, otherwise the project could be permanently shut down. There was only one solution: urgently redesign the fighter. Schwendler, along with a team of engineers, took risky steps, striving to eliminate all the weaknesses of the previous prototype. First, they tackled the wing. To increase maneuverability and control, the wing area was increased, and the span was made larger. This gave two advantages at once. The aircraft became more responsive to the pilot during horizontal maneuvers, and thanks to the wider spacing of the ailerons, roll control improved. However, for the sake of strength, they decided to abandon complex folding mechanisms. In the early stage, it was more important to prove that the machine could, in principle, outperform its rivals. But a truly complex problem was hidden in the tail section. After wind tunnel tests, it became clear that the horizontal stabilizer was falling into the aerodynamic shadow of the wing. This meant that the elevators lost effectiveness precisely when the pilot needed confident control. For a fighter, this could be a fatal flaw. Schwendler decided on a radical rearrangement. The stabilizer was enlarged and moved lower, below the base of the fin. The fin and rudder were also made larger. Such a step required serious design modifications, but otherwise the project would have no future. The work proceeded in a rush, but this stage became the turning point. The fighter gradually acquired the features that would later make it recognizable: a more powerful silhouette, a sturdy tail, enlarged surfaces. All of this was the result not only of engineering calculations, but also of a desperate desire to retain a place in the sky. Thus, the new prototype, XF4F3, was born, in which every line and every detail became a reflection of the fight for survival. In the winter of 1939, the first flight of the new XF4F3 prototype took place at the airfield. The machine soared into the air no longer as a compromised option, but as a full-fledged monoplane, incorporating all the changes born in the rush and under the pressure of competition. It was clear from the start that the fleet was facing not just a refined project, but a completely different fighter, which retained the reliability of the old Grumman machines, but added new qualities necessary for the upcoming war. Tests confirmed that the decisions made were correct. Flight characteristics improved significantly. Control became smoother and more precise. Maneuverability increased, and the aircraft became more stable in dives and turns. Most importantly, it showed sufficient structural integrity to withstand the stresses inevitable in combat. For carrier aviation, where pilot errors often cost too much, this was a decisive advantage. In the summer of the same year, the fleet signed the long-awaited contract with Grumman for the production of the first batch of 54 machines. They received the designation F4F3 and soon began entering operational units. Externally, the aircraft looked rugged and powerful. Its fuselage had an all-metal construction. The nose housed the Pratt & Whitney engine with a supercharger, fuel tanks, and a fire suppression system. The tail section contained the cockpit, an auxiliary tank, and radio equipment. The wing was of two-spar design, with aluminum skinning and integrated armament. It was here that the machine guns were located, which became the Wildcat's main argument in combat. The landing gear inherited the characteristic features of Grumman products. It was retracted into the fuselage manually using a winch, which seemed somewhat archaic, but ensured simplicity and lightness of construction. Thus, the technical appearance of the new fighter was formed, sturdy, reliable, if not the fastest. It didn't yet strike the imagination with records, but its lines already incorporated the character that would enable it to withstand the first, toughest trials of the war, and give its pilots a chance for victory. The Wildcat differed from many of its contemporaries primarily in its simplicity and rugged reliability. Its fuselage was an all-metal structure. The nose section was a semi-monocoque with the engine and fuel tanks. The tail section was a round-section monocoque with the cockpit and radio equipment. This division made the machine durable and easy to maintain, and the armor plate behind the pilot's seat and the self-sealing fuel tanks significantly increased the pilot's chances of returning to base even after heavy hits. The wing became one of the most important parts of the aircraft. It had a two-spar scheme with stressed aluminum skinning and an ACA profile, providing good lift. Machine guns were built into its consoles, which, depending on the modification, could be 4 or 6. The first variants used 4 heavy Browning machine guns with a large ammunition supply. But later, the American military insisted on increasing their number to 6, sacrificing the number of rounds per barrel. Oil coolers were also housed in the wing, and from certain series, the ability to fold the wing consoles manually appeared, which saved space on the aircraft carrier. The landing gear became Grumman's hallmark. It was retracted into the fuselage manually using a winch, which lightened the structure and made it repairable, but also had serious drawbacks. The narrow track and insufficient strength often led to accidents during landing, especially on aircraft carrier decks where the slightest mistake could be costly. Furthermore, the low struts prevented the installation of a larger diameter propeller, causing a significant part of the thrust to be wasted. The power plant included a Pratt & Whitney or Wright 14-cylinder radial engine, depending on the modification. Their power ranged from just over 1,000 to nearly 1,500 horsepower. A variable pitch propeller, just over 3 meters in diameter, allowed for confident RPM control and gave the pilot flexibility in thrust management. Special attention should be paid to the armament. 6 heavy 12.7mm caliber machine guns were a formidable weapon against unarmored targets. A 1-second burst was enough to literally tear an enemy apart. Additionally, the Wildcat could carry 2 small bombs or unguided rockets, and later drop tanks to increase its flight range. All these features created a contradictory image. On the one hand, the aircraft was sturdy, durable, and adapted to harsh carrier service. On the other, design flaws, especially in the landing gear and engine power, did not allow it to fully realize its potential. This combination of strengths and limitations determined the future fate of the Wildcat in air combat. The history of the Wildcat is a history of constant adaptation and the search for balance between the demands of the front and the capabilities of the designers. The first production variant, the F4F3, became the basis for further changes. It received a Pratt & Whitney engine with about 1,200 horsepower and armament of 4 heavy machine guns. This combination allowed for confident combat, but pilots already complained about the lack of firepower when encountering dense groups of enemies. The next step was the F4F4. Here, engineers met the military's demand and increased the number of machine guns to 6. This increased the burst, but reduced the ammunition load per barrel. Moreover, it was with this version that the folding wing appeared, an innovation that allowed up to 1.5 times more aircraft to be accommodated on aircraft carriers. This was critically important for the fleet, as every extra fighter could save a ship at a decisive moment. The reconnaissance modification, the F4F7, stood apart. It was distinguished by the absence of armament, but instead had a huge fuel supply. Such aircraft were used as photo reconnaissance planes, capable of looking far beyond the horizon. Only a few were produced, but they made a noticeable contribution to the preparation of operations. When production had to be sharply increased, the capacity of General Motors was connected. Its Eastern Aircraft Division produced the FM-1 and FM-2 modifications. The FM-1 virtually duplicated the F4F4, but reverted to 4 machine guns, which allowed for an increase in ammunition. The FM-2 received a new Wright engine with a power of over 1,300 horsepower and was characterized by improved takeoff and landing performance. The FM-2 became the most numerous version, with several thousand units produced. British versions, which were named Martlet, also played a separate role. In conditions where Great Britain urgently needed carrier-based fighters, these machines became a real salvation. They fought in the Atlantic, protecting convoys from German U-boats and bombers, and also participated in the Mediterranean. The British appreciated their durability and reliability, though they did not hide the shortcomings in speed and maneuverability. Each new version of the Wildcat did not solve all problems at once, but rather represented a compromise between firepower, range, and ease of operation. But together, they created a whole family of fighting cats. Aircraft that allowed the American and British fleets to hold on during the toughest years of the war, until more advanced machines like the Hellcat and Corsair arrived to replace them. When war raged in Europe and British cities and bases were under regular Luftwaffe raids, the British were in dire need of new fighters. Their own industry was working at its limit. That Spitfires and Hurricanes went primarily to the Royal Air Force, and too few machines often remained for the fleet. That is why the British turned their attention to the American novelty that was just beginning to enter units, the F4F in Great Britain, which received its own name, Martlet. These aircraft began arriving on the islands at the end of 1940 and almost immediately plunged into the thick of events. The first combat missions were not related to aircraft carriers, as intended in the USA, but to the defense of naval bases on British soil. Martlets patrolled over ports, covering them from raids by German bombers. And although these machines could not boast the speed or grace of the Spitfires, they possessed another important quality: durability. Their sturdy construction and reliable engines allowed them to withstand damage that could be fatal for lighter machines. For the British, who at that time lived under conditions of constant threat, the American fighter became a real help. Martlets did not achieve sensational success in the role of interceptors, but their appearance helped to relieve other units, and most importantly, proved that the fleet could rely on its own strength in defense. German pilots soon realized that raids on Portsmouth or Rosyth ceased to be unpunished and switched their attention to other targets. For Great Britain, the purchase of these aircraft had another significance. It symbolized the growing cooperation with the United States. The British showed a willingness to use even somewhat crude but reliable Allied equipment if it could close a gap in their defense. And the Martlets themselves passed their baptism of fire in these first battles, and proved that the Wildcat was capable not only of surviving, but also of fighting back against the enemy, even if not always on equal terms. Thus, The service of the American fighter began in the skies of Europe, an aircraft that was soon destined to become the main defender of a completely different theater of operations, across the vastness of the Pacific Ocean. When the United States entered World War II, the Wildcat was on the front lines in the Pacific. It became the only carrier-based fighter ready for immediate combat, and it was it that had to take the first blow of the Japanese Air Force. These machines defended Guam and the small Wake Island, where a handful of Marines and pilots, operating with virtually no chance, managed to delay the enemy's onslaught. There, the Wildcat had to not just shoot down enemy aircraft, but literally fight for every takeoff and landing, as Japanese attacks did not cease day or night. In the spring of 1942, Wildcats were already escorting American bombers and torpedo planes on risky raids against Japanese bases. When the Battle of the Coral Sea began, they covered the aircraft carriers Lexington and Yorktown. For the sailors and pilots, these machines became a real shield. They shot down dive bombers, drove away torpedo planes, often at the cost of their own lives, to give the ships a chance to survive. But the decisive test awaited them a little later, the Battle of Midway. There, Wildcats became the main barrier between Japanese air groups and American aircraft carriers. Although they were inferior in speed and maneuverability, their toughness and perseverance allowed them to gain time and disrupt the Blitzkrieg plan that was supposed to destroy the U.S. fleet. The victory at Midway became a turning point in the war, and the Wildcats' contribution to it cannot be overstated. However, the Wildcats' main adversary was the Japanese fighter Zero, a machine considered the pinnacle of design thought of its time. Light, fast, and incredibly maneuverable, it surpassed the American plane in almost everything. Japanese pilots mocked their opponent, calling it a soda bottle, or comparing it to a sluggish sumo wrestler. In a turning fight, the Zero easily got onto the Wildcat's tail, and it seemed that the Americans could only await inevitable defeat. But it was here that the Wildcat's strengths emerged. Its sturdy airframe, armor, and self-sealing tanks withstood hits that would have caused the lighter Zero to break up in the air. The engine could continue to run even with serious damage, and the armament of 6 heavy machine guns gave the ability to destroy the enemy with a short burst. Pilots quickly realized that to survive, they needed to use diving and head-on attacks, where the power of their weapons could equalize the odds. A true salvation was the tactic developed by Squadron Commander John Thach. It was called the Thach Weave. The idea was simple, but brilliant. 2 pairs of fighters flew towards the enemy, crossing and exchanging places, so that a Zero, engrossed in attacking one aircraft, found itself under fire from the other. This maneuver allowed them to negate the Japanese advantage in maneuverability and turn the skirmish into a test of nerves. Thus, the Wildcat, despite the mockery and weaknesses, managed to persevere. It transformed from an interim solution into a true fighter, which proved that even when technically inferior, victory is possible through tactics, resilience, and pilot skill. Over time, Wildcat pilots learned to turn their machines' weaknesses into weapons. They knew that they had no chance in a turning fight against the Zero, so they used other techniques. Gaining speed in a dive, the Americans sharply broke away downwards, exited the attack, and climbed again. When they managed to meet the enemy head-on, the 6 Brownings unleashed a short but deadly burst, capable of tearing apart the thinly skinned Japanese aircraft in just half a second. These tactics not only saved lives, but also brought rare but important victories that gradually strengthened the pilot's confidence. Many stories are preserved of how the Wildcat's tough construction helped its pilots survive. Even after taking dozens of hits, the machine could stay airborne long enough for the pilot to bail out or ditch in the ocean. And then the inflatable raft, which was standard equipment, came into play. Thanks to this, many airmen who went down in the water returned to their ships. But behind the salvations, there was always the other side. The narrow track of the landing gear and its insufficient strength led to frequent landing accidents. It was not uncommon for aircraft to break right on the aircraft carrier deck, and sometimes this ended in tragedy for the crew. The Wildcat could forgive mistakes in combat, but it did not always forgive them upon landing. When new fighters appeared on carrier decks, the powerful F-6F Hellcat and the swift F-U Corsair, the fate of the old Wildcat was sealed. It could no longer compete with modern machines and gradually moved to secondary roles. It was transferred to air defense units, escort carriers, and units hunting for submarines. The modifications armed with rockets and bombs proved particularly successful. They were transformed into light attack aircraft, capable of destroying not only aircraft, but also enemy ships. After the war ended, these fighters were quickly retired. Only a few dozen machines, mainly late FM2 versions, survived and are preserved to this day. They can be seen in museums or at air shows, where they serve as a reminder of their time. The Wildcat received many nicknames. It was called a soda bottle, a peanut pod, and even a swallow, but in history it remains primarily as the first of the American fleet's fighting cats, which opened a whole dynasty of carrier-based fighters. It survived defeats and victories, became a symbol of perseverance in hopeless battles, and proved that even an imperfect aircraft can become a legend if a person is in its cockpit who is ready to fight until the end.